welcome back to Tech Simplified channel. In today's video, we will learn. Okay, so let's go through the server code first. So first we start the importing socket for the communication and cryptography for hashing and signature verification. For that we have to import the hashes serialization, and from the asymmetric we have to import the padding also. Okay, so after importing all the necessary libraries from the cryptography and socket, let's first set up the server socket on the local host and port 12345. For that, we have to write first initialize the socket and then bind the socket with the local host and port number 12346. Then the server start listening for the communication. Okay, and when the client connects, we have to accept the connection and print the client address. For that we have to write server dot accept and then print the address. Okay, now when the client connects and the connection are established with the client, then we receive first the message from the client, and then the digital signature from the client, and in between that I am making a use of the time library to sleep for the 1 second so that the cross connection is not there, and we received each and every message in synchronization. And after that we receive the digital signature sent by the client, and at last, we received the public key in the PEM format, that is a standard encoding format for the cryptographic keys. And this public key is generated by the client. Because for the verification of the digital signature, we require the client's public key, so that the public key is sent by the client only. Okay, now after receiving all three things like message, digital signature and the public key, uh, we have to load the public key so that we can use it to verify the message. So this line is for loading the public key, and after that we have to perform the verification step. So we use the public key, the received signature, the original message, the PKCS version 1.5 padding, that is for the RSA standard, and SHA 256 as a hash function. Okay, and in this verification process, if verification passes, the message is printed, and we notified the client that the signature is verified. Otherwise, we have to print the invalid signature and send to client the message invalid signature. Okay. After that, we have to close the connection from close the server connection. Okay. So in this way, we can implement the server side code for digital signature. Okay. Now let's look at the client code. So for the client code also we have to import the necessary libraries. So again we first import the socket for the communication and cryptography for encryption and signature generation. We also use here time for synchronizing the message so that there is a no overlap in the message. Okay. Now this is the client side. So we have to first generate the fresh RSA key pair. Okay. But first we establish a client connection. So for that we required a socket.socket, and now connect with the uh, server with the local host and the port number 12346. Okay. Now we are generating the RSA key pairs. So we generate a fresh key pair using a private key for the signing and the public key for the verification. Okay, and for that we are using a prime number exponent 65537. Okay, now we have to take input from the user that what message client want to send. So for that we have to take input in a message variable and encode that variable. Okay. Now after that we have to create the digital signature. So for creating the digital signature we required a private key, PKCS1 version 15 padding, and SHA 256 hashing. Okay. So and uses the method private underscore key dot sign. Okay. Now we have to convert the public key to the PEM format. So we for that we are using public underscore key dot public underscore byte method, and in that we have to convert the public key into a standard PEM format. Okay. Now we are already connected with the server. Now we are sending the message first and print message sent successfully, then sleep for the 1 second, then send the signature, print the signature sent successfully, sleep for the 1 second, and at last we have to send the public key generated by the client to the server, print that the public key sent successfully, and at last we have to receive the server response and close the connection, because in this server response we get that the signature is verified or not. So for that we require this response dot decode, and after that we have to close the client connection. Okay. Now for running this demo we required a two different terminal, one for the client and one for the server. Okay. But first we have to run the server side code. Okay. So now I am running this server side code first. You can see that the server is listening. Now in the another terminal, I am running this client side code. Here I give a message that hello server, I am waiting for connection. Okay, this message I want to send. Okay, so you can see it, client send first the message successfully, then the signature successfully, and after that public key successfully, and the client responses, that server responses that it is a valid signature. At the server end, you can see that server receives the message successfully, signature receives successfully, now public key receives successfully, and the signature is verified. Hello server, I am waiting for the connection. Okay, so that's how we can implement the digital signatures using the Python and the socket programming. Uh, in the simple way, we learn what is digital signature, why they are important, and how to sign and verify messages in the Python. Okay, so if you found this video helpful, make sure like, comment, and subscribe. Thanks for watching, and I will see you in the next one. Thank you.